Good morning and welcome to our latest edition of Karmayogi Talks, where we will talk today about robotics and where robotics is growing and what is India doing in robotics. I'm very pleased that we have one of India's finest expert on robotics, um, Sangeet Kumar. Sangeet Kumar founded a company called Adverb Technologies. He's an IIT Kharagpur chemical engineering graduate, then spent 10 years at Asian Paints and operations and factory and warehousing and all that, and really understood what is required. And then left that to build an Indian high tech company. We always talk about, we want more deep tech and high tech. So here's somebody who has done that. And that company is really building some of the most advanced robotics around the world. And it is shipping products from India all over the world, and we learn a lot more about that. Under his leader, he started it in 2016, and under his leadership, Adverb has become a global name in warehouse automation and smart manufacturing. So we want to, in today's talk, uh, we will talk a little bit about robotics and his personal journey. So I want to start out, first of all, Sangeet, thank you very much for joining us. And can you just start out with the basics, which is what all is considered robotics? When somebody says robotics, what is robotics?
Okay. Thank you, sir. Thank you for having me on the show. So robotics, this journey started in 1975, 80s, when for the first time robotics started getting used in assembly line production, and which was car industry. So most of these innovation, whether it is PLC or robotics, it started with car industry. So these were the first robots, and unlike general perception that it was used first in Germany or first in Japan, it was the first industrial robots were used in General Motors factory, which was a three-axis robot moving item from one place to another, which is in US, and the company was in US. It went bankrupt, and a lot of other companies came up out of it. So this is where the robotics journey started. Till 2000 or 1995, 2000, there were several robots which came into picture, and these were mostly industrial six-axis robot. So what is the axis? So any movement, so in our hand you have soldiers moving at elbow and wrist, etc. So those are axis, the first six-axis robots started coming, and they were getting used in industry, and mostly again from automotive. The whole journey was in automotive, to some extent in food and pharma. So these were the industries where the robots started getting used. The robotics was about precision. It was about X, Y, Z position in the space from one place to another place, X1, Y1, Z1 place. And it used to do with extreme precision. The repeatability was great. Even if you do it continuously for 1 million cycles, still it will pick from XYZ and go to X1, Y1, Z1. And these were the two characteristics which made robotics very popular in press shop in car. So car body, when it gets made, so you need to press it so that the steel takes the form of a car. Or in a welding setup, so you start from one place and then you keep on welding till you reach another place. So, and precisely without going here, and these precisions were to the tune of in millimeters. So this is how robotics evolved, and people kept on making it more efficient, more. The journey was about reliability of these products, and a lot of Japanese companies like Fanuc and Yasakawa and Fuji and Mitsubishi, Epson, all these came into picture. Now, Mitsubishi and Epson, and they concentrated in another industry, which is electronics manufacturing and semiconductor, where it was not about it was not only about precision of movement, but also about how small and what less payload it can do. Because here you had to screw a bolt in a mobile phone, let us say, or on in a television, or in a semiconductor industry, taking the wafer out of the food. So these were some of the applications where the smaller robots started becoming popular, and the electronics industry became another consumer of large number of robots. And this is the journey. And again, so it was Japan, and then Germany and Europe. So KUKA came into picture, or ABB came into picture, and they ruled the world for till let us say 2000. And the way people measured the industrial acceptability of robot was how many number of robot gets used per 10,000 of workers in the industry. Now,
I say,
this was the, and this is a very common thing, and everyone will tell you, okay, South Korea is the best with 1,200, 1,100 robots per 1,000 of people, and India is very less, and China has grown significantly from 100 to now 350 or 400, and but that limits the denominator to a particular kind of robot, which is industrial robot. Now, or six-axis robot. And also the development which happened from 1980s to 2005, 2010 was in the payload of robots. So the robot could lift 100 kg, 500 kg, 750 kg, and some of them 1,000 kg payload as well. So this was one phase of robotics, and this continues to be an important form of robot which is there in the industry getting used. Then came cobots, and at the same time there were the autonomous mobile robot.
so this is what cobots is, what collaborative robots. What does co stand for?
Yes. So all these industrial robots were always fenced. So
Oh, I see.
humans cannot approach these industrial robots because the speed at which they move, or the thrust, if it hits you, there was a popular Hindi movie as well where you can see the robot hitting a person, and it can be fatal. And therefore it had to be fenced. But what happened with cobots is, and it was happening in research institutions for many years, but some companies, Rethink Robotics from US and Universal from Denmark, they decided to bring it to the industry. So for lighter loads, what they did was, in each of these joints, they put torque sensors. So if they touch any obstruction, and that obstruction can be human being, it stops. So it does not, it can hit the
Harm.
person,
Oh,
but
so
it
it
is
doesn't
not.
harm anyone, right?
Yes, yes, yes. And what it enabled is the same workspace can be used by humans as well as robots,
I
and
see.
therefore cobots, and therefore collaborative. It was about workspace getting used commonly. And so what it enabled the industry to do was certain activities where humans are extremely good, whether it is grasping, vision, hand-eye coordination, etc., and certain activities which are monotonous, dull, dirty, dangerous, and all those kind of activities, cobots were doing. So in the same workspace, and which enabled the industry to use it for much larger use case than earlier it was using. So this is the advent of cobots, and this happened in 2005, 6, around that time. And then came autonomous mobile robots. So there is this DARPA challenge wherein the LiDAR.
Sangeet, could you just explain for our viewers what is DARPA? Not everyone might know what is DARPA.
Okay, so it is a defense challenge in US, and where in every year they take one technology and say, okay, can someone crack this technology? And that gets used either in space or in defense, and mostly in defense. And one of the challenge was autonomous driving of the car or any vehicle for that matter, and where you don't need drivers, and the car or the robot itself can figure out the road, the lane, and then it can travel. For that to happen, one of the most important sensor which had to be cracked was LiDAR sensors. So these sensors are the sensors which creates the map of the area on the go. And there was a technology which is SLAM, which is simultaneous localization and mapping. I'm sorry I'm using this
No,
word,
right, right.
but this is the
So
way.
this is Sangeet. So this is basically what ultimately led to the autonomous driving cars of
Waymo.
Waymo, Tesla, and
Yes,
BYD, and all of
yes,
these people,
yes,
right?
yes, yes,
Okay.
yes, yes. So the first such, so Velodyne came into picture, which made these lidars, and then they won. There were 6, 7 people in the team which won this competition, and they became the startup under Google for Waymo. So
Ah,
these
okay.
were
Right.
these people who won that game. But so the base technology started evolving during that period. And but before you take it to a road, which is extremely messy in comparison to a factory or a warehouse, which is still very controlled environment. It is not that controlled, but still controlled. You have workers who knows and they can walk in a particular path. Whereas in roads, the cars are moving at 100 kilometer per hour. It can rain. It can have a tree falling, and all those things. The variability or the nature of variability or the edge cases were much more, and therefore the first cars which came on the road took 15-20 years from that DARPA event. But the first autonomous mobile robot to carry item in a warehouse or in a factory from one place to another, that came much earlier, and that was what was autonomous mobile robot. And there was this company Kiva, which was taken over by Amazon later on. They excelled in building these kind of robots and for moving racks in a warehouse, etc. So that was the advent of the other era
Okay.
in robotics.
So far, Sangeet, so far, well, two questions here. One is, so this is what Amazon has put hundreds of thousands of these in their warehouses, right? That's what you're talking about. And
Yes.
second, so far, you don't have human-looking robots, right? These are all funny shaped machines or funny shaped arms or something.
Okay. Yeah. So yes, you are right. I spoke about industrial robots, cobots, and autonomous mobile robots, and from the industry perspective. But parallelly, what happened was, and each of these technologies, if you see, it comes into imagination first, and then the technology evolves, or someone decides whatever has been imagined, let it make it true.
Oh, it's
and
okay.
and that is what happened. So the movies started coming of humanoids, and some movies you already named. And then companies in Japan, and particularly Honda, uh, they excelled at that, and they made the first robots. If you remember Asimov, which was the culmination. Everyone thought, "Wow!" And it worked, and
So, Sangeet, this is you are talking about Isaac Asimov, the great sci-fi writer who wrote a
yeah,
series called I, Robot, right? That's the guy.
yes, but in his name, Honda made a robot on his in his name.
Oh, I see.
Yeah, yeah. So Asimov, in fact, the first law of robotics, second, third, all comes from iRobot or Asimov's book. And where in the first law of robotics, and I will talk about it, is it cannot harm human being. That is the first law of robotics, and everyone is trying to ensure that that first law of
Hmm.
robotics, no one touches it. Or no one goes beyond that. That is the ethical or the edge. Yeah. So then humanoid started in Japan, as I said, and then what happened is in the last 5 years, it has just boomed, and there is a purpose, and there is one. There is a purpose why it happened. So there was large language model which came into existence in AI, and we know about large language model, whether it is from ChatGPT, from OpenAI, or Google Gemini, from Google or Meta Llama, and all these large language models or DeepSeek, etc., started coming. The same company started building vision language model, VLM. So LLM and VLM, and these are the two base technologies or the transformer technologies, which are the base of what you do today when you use a chat GPT or when you use any other perplexity or anything like that. But uh, 3 years back, and it was Google's paper, RT1 and RT2, which was on vision language action model, and this created the change. And so earlier humanoids or all kinds of robots, you had to program it from moving from one place to another or doing activity from one thing to the other thing. Now with VLA, you don't program it. It is so you talk to it, and it is still at a very nascent stage. So we cannot say it is very matured, but it has shown the light where and what robotics can achieve. And so just imagine
So, Sangeet, can I just to push you on this, right? So, can I today do something, or will it come soon where I can say, Raju, please get my tea?
yeah. So you can do it today.
Oh, you
Okay.
can. Okay.
Yes, yes, and there are several companies and the kind of investor and okay, with Tesla and Google and Meta, these are the big three, I would say, who are making this possible. But then there are companies like Skilled AI or Physical Intelligence or we in India, and then there are a host of Chinese companies. There are in the last 3 years, there was first Chinese company which was Unitree, and then DeepMind, and today there are more than 40 companies which are trying to do this, and this is China at its best. And
Wow.
what people are talking about is physical AI. So it is AI was a revolution, and it is still continues to be. That first break came, and then it is evolving. Similarly, the first break is coming in physical AI, and you just said uh, X, go and get this T for me. So what happens is, let us say a robot is standing in a corner of the room, and you order a humanoid, you order that robot to go and get a glass of water. So you say, robot, get me a glass of water. What happens then? So all these three models, large language model, VLM and VLA gets activated, and tokens from one model goes to another model, etc. And finally, it makes the robot to do the activity. And what happens basically, I'm in a very common language, I have tried to explain. So when you say, go and get water for me, the robot has to understand that what is water, where is it kept, in what glass or form factor it is kept, is it kept on table, in a kitchen, where it has to go. So all this comes from large language model, the base
I
model,
see.
the physics, the intelligence, the reasoning level. Then robot is a physical thing. It has to understand the environment. The first, you have made it understand the context, not the environment. Like human beings, it has to see the room, see the table, see the obstruction, let us say chair or some toy which has fallen on the ground. Now, all these robot has to have the perception like human being, and it has to, so the understanding the environment is the VLM model or the vision language, which says the different form factors of different items. Then there is action model, wherein the robot has to walk stably without falling, and then go there and pick, put his hand in such a way that it can grasp that glass and then bring it to you, which is the action model. And this is the most difficult part right now in this whole entity of LLM, VLM, and VLA, which makes physical AI or embodied AI. And this is where the world is moving, and it is improving every day. So NVIDIA has come up with Groot. Google Gemini robot has come with another model of theirs. There is physical intelligence which has come up with their model, and a lot of these models are coming from directly from research labs. So professors of Berkeley and Stanford coming together and building a model and then using it in certain form factor of the robot, or professors from Carnegie Mellon University or professors from ETH Zurich. I'm sorry.
I noticed that you, Sangeet, you didn't mention any professors from India. Is it because this research is going somewhere else, or is it that in the Indian system we are not seeing that translation from idea to actual product that quickly?
No, it is not like that. I know a lot of drone companies which have been started by professors now.
Okay.
And is one of them. He is my batchmate from IIT Kharagpur, and then he is now a professor at IIT Kanpur. But also, there are robotic dog companies in ISC Bangalore, which has started. So, but this VLA is just 1 year, 1.5 old concept. And the kind of money it requires, I don't think Indian universities have that muscle power right now, or the intent is there at this point of time. But there are companies in India, entrepreneurs who are started. Okay, we are of course working, and I'll talk about that journey anyway. But this is the space which is the amount of investment. $20 billion has gone in last 2 years just to, and China, I spoke to you about, you see YouTube videos every day on a humanoid doing this, jumping, all those things which are happening. Now that is nothing but manifestation of embodied AI or physical AI, and it is just a start. I would say the form factor which will be most acceptable, not in industrial scenario, six axis and cobot and AMRs, autonomous mobile robot, etc., is accepted. But in homes, in healthcare, assistive living, all those places, the form factor which we, because the whole world is made for humans, and we have designed the houses and kitchens and bathrooms and hospitals and elderly care institutes. Everything is made for humans. So the form factor which will work the best is humanoid. And the kind of research which is happening in social robotics and how it can talk to you and ensure that you don't feel lonely, etc., etc. So there is a lot of things which is happening. And this is the golden era of robotics. I think
I see. Okay.
it's 10 years. So 1980 it started, but from 25 to 35, it is the golden era of robotics. And it is because of the maturity of the hardware, maturity of the software, and this VLA coming into existence because of LLM and VLM being
So,
successful.
Sangeet, just give us a few numbers. So, today, let's say the world is making, I don't know how many, 100,000 robots that are humanoid. And in 10 years' time, they will make what, 20 million? I don't know. Give us some idea when you said it's
Yeah.
the golden age.
Yeah, so I'll just tell you total robotics. I would say today in the world there would be not more than 100 million robots across. Even in the last 40 years, it has happened across different form factors: six-axis robot, cobot, AMR,
Everything. Yeah.
everything, surgical robot, everything put together, it would be 100 million robots. And what is and a lot of people are predicting, there are McKinsey articles, there are Elon Musk himself predicting by 2050 there will be around 8.5 billion people on earth, and there would be 8.5 billion robots. And that is the opportunity. So from
Wow.
100 million to 8.5 billion.
So,
In
one robot per person.
one robot per person, like mobile phones. And the cost of today, and why it will happen, is the cost of humanoid. It used to be 2.5 crore, 3.5 crore, just 1.5 years back, just 1.5 years back. But as the volume catches up, and Elon Musk predicts it will be 30,000 US dollar, which comes to around 30 lakhs and 40 lakhs. Chinese companies are giving it in 15 and 20 lakhs, and it is happening now. It is happening now. It is
Wow.
not. It is. It is not that industrial. It is not that efficient, and reliability is not there. It is not that safe, but it has come. It is like a car, and that is why Elon Musk says it is the new car industry which is taking the sale, because it is personal mobility, a personal care thing. I know for certain, I cannot name the company because we have signed an NDA. That company, very large company, one among the top 10 companies in the world, not only in AI and others, they are trying to launch a robot in 2027 to target human homes, where these robots will tidy your bedsheet or do the course, the yeah, cleaning of your kids' room, cleaning of bathroom, cleaning of or cooking food for you, and daily course. Lot of these things will get done by these robots. So robots which are today in industry or healthcare or warehouses, will come out and then will be in your homes. Not only that Roomba robot which cleans
Yes,
the
I know. I have one of those. Those are pretty good, actually.
yeah, yeah, yeah. So that those
So,
kind of
Sangeet, are you saying that in the past robots were industrial robots, and in 10 years from now, a huge number, the majority will be humanoid robots, not industrial, but for consumer use,
yes, for consumers and not necessarily completely humanoid, but a form
a
factor
form factor. Okay.
which is very similar to humanoid. So and the commercial robots or the robots for homes will be a large chunk of these robots. The industrial also will today. If you see where has the technology evolved and with these VLA models, etc. One is reasoning. You don't have to program anything. The robot which has been trained to do, let us say, 1,000 activities, the 1,001 activity which it has never done, it figures out the way we figure out by reasoning. If we go on an
Yeah.
adventure and we are walking or trying to hike a mountain and we figure out how do we do it because we reason. Same way the robots will start reasoning, and it is still reasoning. It has started reasoning. It will become much more mature. So the human eye coordination which we are in robotics world, there is something known as Maslow's principle, wherein it says that anything which humans have learned in last 200 years, it is very easy for the robot to replicate. But
Mm,
anything which humans have learned in the last 2000 years, which is walking and hand-eye coordination and very basic primitive things. If I am transferring this thing from my one hand to another, all I don't have to think. My other hand comes at that place simultaneously at the same time in the same space, and then I know when to leave and when to pick and at what pressure to catch and what all these tactiles for the robots to make it possible. And we have done it now in our company. And there was a research paper which we published in ICRA, which is the best robotics research thing. And this to do this to make this possible, it is extremely compute heavy job in the robotics world today. And those are the things which came very natural to us and which we learn in our when we come to the world in 0 to 2 years or 0 to 3 years of our birth time, infant's lifetime. That is the kind of work which robots are learning now at much faster because of the vision and the vision giving signal to the brain and hand-eye coordination, the sensing, the tactile sensing. So those are the things I think are the last pillars of technology which robotic world is evolving.
great. So, Sangeet, it's wonderful what you've talked about overall in terms of robotics. And before we get into what is Adverb doing and what is happening in India, I think you had a little video you wanted to show.
Yeah, okay. So this is something which we have done in Melbourne, wherein the robot. These are autonomous mobile robot, and it is carrying load from one area to another, and it goes and then stores in one of the densest form of. So you want to use the complete infrastructure or the complete volume in a building, and there you need robots which can go high up and then bring the material which is required for the customer, whether it is e-commerce or retail. Then these are smaller robots, the zippy robots, which goes, and these are all mobile robots. You also saw the industrial arm, which was working. Now, these are some of the robots that we do, and there are more than 400 robots at that facility. This is a lens cut facility wherein you build eyewear in. So what happens is the moment customer gives a order, within 20 minutes you have to pick the frame, the left eye lens and the right eye lens which customer has chosen, and then it goes for manufacturing where lens is cut into the frame size and then fitted and quality check and packaging, and then distribution happens, because from this factory it has to go to all over India on the same day. And then so distribution according to the city, then distribution according to the courier company which will bring this
So,
material.
Sangeet, this is an actual live facility in India.
Yeah, this is an actual live facility in India, and there are
Wow.
several. So today, yeah, and this is one kind of robot that we do extensively. The other kind of robot I was talking about is this kind of robot. This is cobot. So this is collaborative robot. So you can see this collaborative robot doing the welding. So welding was done by 6-axis robot as well, but in collaborative robot, or it is doing the pick and place from one place to another, humans can be there in that same workspace. And you use these collaborative robots, and I'll talk about it a bit later as well. Because you asked me this question regarding what industry or what universities in India are doing. And the other kind of robots are these quadrupeds, which is four-legged robot. So it started with dog, and then Chinese media made it. So there was this big. If you remember, on 3rd or 4th of September, there was this Victory Day parade in China, where they have said wolves, and Indian Army requires the version which can carry load. So it is mule,
Okay.
digital mule. So these kind of robots, and we have deployed it in our factory, and we are now giving it across defense and across inspection and surveillance in factories and in power sector, nuclear power sector, etc. And it has all kinds of cameras and sensors, and it is your a mobile partner which goes in areas where you would not like to go, and it collects data for you from in different forms. And these are the other kind of robots which are becoming very, very popular, apart from humanoid form factor. And this is our humanoid, and this is a biped, which is with 2 legs. This is with wheels, and I was talking about this vision language action model, but these are some of the learnings. And today, the robot learning and the amount of data available for the learning is the biggest challenge. So for large language model, yeah, so it will recover, and then it starts moving again. So different terrains, and this is not, you cannot have a physics solve this problem, and so there is a model predictive control, or the mathematics and physics. It is reinforcement learning, wherein you reward certain action if it makes you walk again, and you give punishment, or you reduce the marks because it was not able to lift again.
Wow.
And this is reinforcement learning, and then there is imitation learning, and which is what I was talking. This technology today, because and this is the paper that we published, wherein so you just simple task of one giving a bottle from one end to another, and this was our first humanoid form factor, but now we have evolved from this form factor. Or if there is an obstacle which is coming in between, how do you go about it? So these are some of the things which is changing in the current humanoid or
Okay.
robotic
No, no.
form.
So what you're saying is it is moving very fast. All it's moving in conjunction with AI because AI is helping you do many of these, make these
Yes.
form factors work, right?
Yes, yes, yes. And earlier it was just not possible. Today, because of AI, and it is not that specific AI was always available, and robotics world was using it. But the generalist one with LLM, VLM, and VLM, wherein you are not trained it for that activity itself, and the robot figures out to do that activity by reasoning or by some experience which is very near to the experience which it is able to relate to, and that is huge. That makes things possible, because homes, if it has to come to homes are the most unstructured environment. Everybody's home is unique. And
Right.
because the human behavior will be different in one part of the geography than another part of the geography. Kids can be very innovative in throwing items, and how do you make that possible is what the largest.
Right.
Yeah.
I just want to. This is terrific, and there are many aspects that we can, talk about. I wondered if you could spend 2 minutes talking about, many industries like AI has all these larger than life characters in it, right? You have Sam Altman, and you have Demis Hassabis, and all these people who are, living legends in a sense. In robotics, is it mostly behind the scenes, or are we also seeing some crazy people emerge in this? Crazy in
No.
a good way. Sorry, Sangeet.
Yeah, yeah. So there are really, really great people in robotics which are coming up. Marco Hutter is one person. He is a professor from ETH Zurich. And then Mark Rybert, the CEO. So he was professor of in ETH Zurich, and also co-founder of a quadruped company, the legged robot, Anybot. And then there is Mark Rybert, who was the CEO of Boston Dynamics, which is again another company which is making. And then companies like Google and Tesla, you don't have a particular name; it is the whole
Right.
organization which is there. Unitree, which is a Chinese company, Jing Wang, that person is maverick as far as robotics is concerned. The If you see in particularly, these are humanoid companies which I spoke of. But then there are two companies, and the CEOs of Deepak Pathak. He's an Indian from IIT Kanpur, and then he did his master's and PhD at CMU. He was a professor at CMU. He is the CEO of Skilled AI. He is one person who is making a huge impact in the robotic world. Similarly, the CEO or the co-founders of Physical Intelligence, Sergey Lin, he's making a big impact in what. So these are few global names.
Okay. But I'm glad to see that there are some Indians from IIT over there
Yeah,
also.
yeah. In fact, and I did not speak about Google or Meta or Tesla. The top leadership there, and we were in one of the meeting with these people, and American company. There were 6 representatives from that company. 4 were Indian, 2 were Chinese. American company.
Oh, really? Oh, my, that's,
So
I guess that's both good
robotics,
and bad. Yeah.
robotics world, of course, Indians who have moved out of the of India and made their mark in US and Europe. But there are Indians. So I have a person, Dr. Rajesh. He is heading our advanced robotics, and I think he's one of the person who will make, or he's making India proud. BTech from IIT, MTech from IIT, PhD from IIT, one of the president's gold medal in each of these 3 places, BTech, MTech, and PhD. And the kind of work he has done in last 4 years in our company is exemplary, exemplary. So there are robotists in India also who are making huge difference in this space.
Can you talk a little bit about how did you think about starting this company and what's the journey been like? And then I want to talk about what is India overall its government policy on robotics.
Okay, so as you introduced me, we were working for Asian Paints. I did my chemical engineering, and so no relation to robotics. But I used to work for. So when I completed my chemical engineering, I joined GAIL India Limited, and for 2 years I was there because a chemical engineer has to work in refinery was the thing which I was taught at IIT, and I wanted to see a refinery, so I worked there in a LPG recovery unit, and then for 14 years for Asian Paints. And I was very lucky in the sense that when I joined Asian Paints decided to build world's largest factories and world's largest warehouse in paint industry. And I had an opportunity to visit more than 50 paint companies across the world and see what they were doing, etc. And I quickly realized the kind of factory which we were thinking of building, no paint company in the world has it. So then we decided to go to other industries. So retail industry, we went to beverage industry, both alcoholic, non-alcoholic, and all these factories, around 200 factories outside India, mostly in Europe and US and Japan and South America. And we learned a lot, and we understood how these factories have to be built. And we started building it, and in the process, we bought a lot of robots from Europe and Japan and US. And when we were implementing it, we found a lot of challenges because of Indian conditions. One is heat and temperature and dust and humidity, and then abuse from people because of lack of knowledge. And yeah, so learned a lot. And I thought, and then we kept on doing this every third year. Every third year, Asian Paints was building a factory which was world's largest and world's most automated. And the way we were growing, so was involved in each of these factories. And every time we were building this factory, I used to think, we can make it in India now. We have enough knowledge, and why is that there is no Indian company there? So in 2016, there was this startup environment, and we said, okay, what will happen? Let us do it. The worst what can happen is we will earn only 2 lakh rupees per month, and that is worst which can happen. So we left Asian Paints, 4 of us, and then we started Adverb. And by God's grace, it has been really great journey. We grew from 0 to now more than 1,000 people in India, 150 people outside India. 40% of our revenue comes from India, 60% from outside India, overseas market. We have 100% subsidiary in US, Europe, Australia, Singapore. We build robots in India and deliver it to 25 countries. We wish in the next 5 years we will reach to 100 countries, delivering all these different kinds of robots, mobile robots, cobots, quadrupeds, humanoids, and yeah.
Well,
Uh,
this is fantastic journey, Sangeet. Congratulations. It's always wonderful to have Indian companies becoming world-class leaders. And clearly you become a world-class leader in this. I didn't even know the different kinds of robots that existed, and you opened our eyes and what are all the different kinds of robots. Can you talk a little bit about two things? One is just what is what's the government policy on robotics, if at all? And secondly, also, how aggressively are Indian companies not building robots, but starting to use them?
Okay, so as I said, when we started, today we are $100 million revenue company, and maybe in the next 5 years we want to build $1 billion, and out of that, 40% comes from India. So, and
Yeah.
when we started, 100% used to come from India. So, Indian companies are using it. That is the first answer, because we are getting a revenue, and it is not only we are the largest in India, but there are a lot of Japanese and German companies who are second and third, whose products people are using it in India, but also a lot of Indian companies. So today, I am aware that there are at least 25, 30 Indian companies, and some of these companies, these people used to work for us, and they left us, and we have supported in their journey of scaling up their company. So, robotics company in India, and really interesting robotic companies in India are coming up. So, yeah, and they are selling in India as well. So, yes, Indian customers. And who are these Indian customers? Any Indian customer who has achieved a scale of operation. You cannot have. So today, Flipkart, let us say, does 1 million, 1 million orders a day during peak from one warehouse. You cannot have 100,000 people working, or 20,000 people in that restricted area. Even if manpower cost is effective, when you reach a scale for repeatability, for reliability, for accuracy of operation, and for making that scale work for you, the only way is you have to automate. And some of the jobs, and I'll tell you my story in Asian Paints. When we used our first robot, and I remember very well, we had done a study wherein so people used to lift this 30 kg 20-liter paint bucket, which you see everywhere in India. It is omnipresent because of the repeatability. You use it for cleaning, etc., etc. So these 20-liter pails, if you lift it 8 hours in a shift, and for 4 hours or 5 hours, we did this study, and we realized there is this. So after 5 years, people used to complain about their back pain, and we used to then shift them to some job which was in laboratory or something else. And so it was. There is something known as MSD, muscular skeletal disorder, which happens because of the repetitive job which you have to do, and which is 20 kg or 30 kg lifting. After getting and believe me, at that time or even today, there are very few companies, even multinationals, who do not get this study done in the industrial environment. Amazon US has done a very good job as far as MSD is concerned. Now, we got this study done, and we said, okay, how does it happen outside India? And we found out that it happens with robot. We tried it once, we failed because of the paint design, and then we did it again, and we passed. And I remember the discussion. There were senior leadership in Asian Paints, and someone said, The cost does not get justified. Even I put 10 people, one robot at that time, way back. The robots were really costly. And the big boss, the CEO said, if I don't want to create a job which creates problem to my people, and we were expanding really quickly. And then we did one robot, and after that, we never looked back. 200, 500 robots, and that is how I learned robotics.
Okay. From the
So
user perspective, right?
yeah, from the user perspective, and also how it fails and why it fails in Indian conditions. And this, the fact that someone took a decision when even when ROI was not justified, is the kind of decisions, because he said, oh, what is happening to the health of the people, and whether it is dull, dirty, and dangerous job, the 3Ds which robotics typically replace in industry. And this is how the journey started. And once you, and everyone asked me, so the job of those people got eliminated. Yes, it got eliminated, but what did we create in return? There were, in my team itself, I had engineers to take care of those robots. I had technicians which could maintain the thing. I had supervisors because you had to see the robots. And
Yeah. No, no. So,
so
Sangeet, you're making a very important point, which I was going to ask you and I forgot, which is, as you look ahead, you don't see robots. At the end of the day, the robot industry creates jobs, not replaces jobs. Is that
of
what you're
course,
saying?
it creates job. It creates job because of two reasons. One, and the kind of job. If someone is employed for lifting a load from one place to another, what will he get paid or she get paid? X amount. Because it is a very job which you are not assigning any skill to it. The moment someone is taking care of a robot, and not only a robot, the pay increases to 3x. And that is one. So you have created a value added job. Second is you have created a skill in that person. The second is, if you see the number of people which gets reduced is equivalent in number of high-end job which you have created because you have deployed robotics. And this is true in industry, definitely. And not only in my roles, Asian Paints role, but also suppliers roles. Well,
Mm,
maybe has to have so many people to sell and maintain, and yeah, or Adverb has to have. So if you see the ecosystem, you have created enough number of jobs. So this misconception that robotics will kill the job and India is not ready, etc., it is absolutely not right. Now that is from one perspective. The other perspective I have is, the day, and I know from my experience, the day I deployed robotics, the kind of productivity gains which were not there in terms of losses, that makes industry much more productive. You want your industry to be productive to match the productivity of China or some other country,
yeah.
so that you can sell it across the world. You don't want to restrict yourself to the market in India. If I am a company which is building a product which is world-class product, then I need to sell it across the world. And that can happen only when I produce it in a cost which is equivalent to some other country's cost. And that can happen if you have automation and robotics. So these, on both the fronts, I am very much convinced. And I have thought over it a lot. I have experienced it, and I keep on experiencing. I have been having this experience in the last 9 years as a supplier of technology. Earlier, it was the user's perspective. Now, as a supplier of technology, I feel the same, and I feel it very strongly.
No, this is terrific. Sangeet, thanks. There are many other things to examine, but I think we are running out of time. We can all see the incredible passion you have for this. And I think we're all very excited that an Indian company and many Indian companies are now among the leading robotics manufacturers worldwide, and also that many Indians are heading robotics companies or robotics research at the leading universities around the world. So, Sangeet, thank you so much for doing this. And I guess if we talk to you in another year, you will have a robot sitting next to you answering your questions.
Of course, and that is definitely possible. And it is, as I said, it is the industry of future. There is no other industry which will evolve in the next 10 years the way robotics will evolve. And yeah, we need all kinds of support in building the ecosystem. We are doing our bit, and I hope India becomes the large robotics supplier country in the world.
Thank you so much, Sangeet.
Thanks, sir. Thanks for
Thank
having
you
me.
and good luck. Thanks.